Hi everyone, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So the next topic in the lecture series is improving coverage and capacity. So as the number of users keeps on increasing day by day, definitely improving the coverage and the capacity of the cellular network is important. Mainly capacity improvement is very important. So we will see the techniques that are used for improving the capacity and coverage in a cellular network. There are three different methods for improving the capacity. One is cell splitting, cell sectoring, and microcell zone concept. So in the cell splitting method, we are subdividing a congested cell into smaller cells. Whereas in sectoring method, instead of omnidirectional antennas, we'll be using directional antennas in order to reduce the interference. Next one is microcell zone approach. Here, distributing the coverage of a cell and extending the cell boundary to hard to reach places. We'll see each method in detail. First one is cell splitting. So cell splitting is the process of subdividing a congested cell into smaller cells, each with its own base station. So with corresponding reduction in the antenna height and also the transmission power. So cell splitting, it will increase the capacity of the cellular network since it increases the number of times the channel is reused. Once you reduce the size of the cell, definitely more times you have to reuse the channel. So when your frequency reuse increases, definitely the capacity of the network will get increased. So you are defining new cells which are smaller radius than the original cells, and you'll be installing base stations separately for these microcells. So capacity increases due to additional number of channels per unit area. So this is how cell splitting is done. So you'll be dividing a large cell. You'll be dividing a large cell into smaller cells only in those places where the area is congested. Not all the cells will be subdivided. So you'll be preserving the same frequency reuse plan as shown here. And then for the small cell also you'll be using G here, also G here. So same frequency reuse plan will be uh, preserved here. And also the transmission, since the cell size is getting reduced, the transmission power of the antennas used in the small cells will be reduced. So here you'll be having different cell sizes and different uh, transmission power of the antennas. So here the cell size is reduced from R to R by 2, where R is the radius of the cell. So a study shows that um, for old cell boundary, your power is PT1 into R power minus n, where n is the path loss component. And for new cell boundary, it will be PT2 into R by 2 the whole power minus n. So if when you consider n is equal to 4, then you'll be getting PT2 is equal to PT1 divided by 16. So the drawbacks here are you'll be having different cell sizes. So there will be high speed and low speed users. So because of this small cell size, more handoff will be needed and handoff rate will get increased. So also the handoff between the cells and the microcells have to be taken care here. This is main disadvantage of cell splitting. Next one is cell sectoring. So decrease in order to avoid reduction in the cell size, we are going for another method which is sectoring. Here we are not going to subdivide the cell. We are not going to reduce the size of the cell. Instead of using omnidirectional antenna, we will be using my multiple directional antennas, more number of antennas instead of a single antenna. Here there are two types. One is uh, you can use either three directional antennas or six directional antennas. So this is a diagram which shows about the different sectors. So 360-degree cells means only a single cell. 120-degree sectors means you'll be having three cell sites. Each cell site will be having one directional antenna. And 60-degree sector is there where you will be dividing it into six cell sites with each cell having a directional antenna. So here is a diagram which shows how the interference get reduced in the cell sectoring method. See, if you are using omnidirectional antenna, so this particular cell 5, it will receive interference from all these 6 cells because omnidirectional antennas will radiate the power in all the directions. So all these 5 cells will provide interference with the center cell. So instead of omnidirectional antenna, if you are using directional antenna, as shown in the figure, your radiation will be only be in this direction as shown here. Okay, so now if you consider this cell, so here you will be getting interference. This cell will get interfered. This cell will get interfered. This cell will not interfere because its boundary is over here. These two cells will be going in only forward direction. So these 3 cells and this cell will not cause interference to this cell. Only these 2 cells will cause interference. Okay, so if omnidirectional antenna is used, 6 co-channel cells will cause interference, whereas a directional antenna is used, only these 2 cells will cause interference. So the number of interfering cells is getting reduced by the cell sectoring method. So the co-channel interference is get reduced. Once the interference gets reduced, automatically the capacity of the network will get increased. So this method also has several advantages and disadvantages. So here the signal to interference ratio is getting increased and it reduces the interference, which in turn increases the capacity, and it enables to reduce the cluster size, and provides an additional freedom for channel assignment. The limitations here are more number of antennas are needed, and the trunking efficiency is getting reduced, and loss of traffic is also present here. The better method from the previous two methods is a microcell zone concept, because the previous two methods have the disadvantages like more number of handoffs, then more number of antennas. Okay, so all these can be solved in this microcell zone concept. So the aim of creating a microcell is to increase the capacity of the cellular network where the population is very high. So here what we will do is microcell zone concept, it leads to an increased capacity without any degradation in the load and switching caused by the set train. So large control based system is replaced by several low power transmitters on the edge of the cell. So this is a diagram which shows the microcell zone concept. So here a particular cell is split into different zones, and the transmitters are placed at the end of each zone, and all the 3 zones are connected directly to the base station. So here you are having only one base station, and this connection from the base station to these zones will be an wired link. It will be a microwave or fiber optic link. Uh, a channel will be active only in a particular zone in which the mobile is traveling. The base station radiation is localized and interference is reduced. So when a mobile moves within this particular cell, handoff is not needed. So no channel reassignment is done, and switch the channel to the different zones. And the channel will be automatically shifted from one zone to other. No need of handoff here. And also interference will get reduced because you are using low power transmitters in each zone. So all the 3 zone sites represent transmitter and receiver, which are connected among themselves. So automatically the mobile traveling from one zone to other zone, the channel also will be moving. The channel will not be reallocated here. The same channel will be used within the zones. This is one main advantage of microcell zone concept. So as a mobile this here, as the mobile moves from one zone to another zone, handoff is avoided, so which is a very great advantage here. Thus a given channel is being used only in the particular zone in which the mobile is traveling. So since the base station radiates its power in a localized manner, it will greatly reduce the interference, and channels are distributed in time and space by all the zones and are also reused in the co-channel cells. So this microcell zone concept is very useful in highways or in urban areas where mobile traffic is very high. So main advantages are reduced co-channel interference, improved signal quality, increased system capacity, and no degradation in the trunking efficiency. Hope you understand the different methods like cell splitting, cell sectoring, and microcell zone concept which are used to improve the capacity in the cellular system. Now let us see few assessment questions. Which of the following techniques do not help in expanding the capacity of a cellular system? Sectoring, scattering, splitting, or microcell zone concept. Yes, of course it is scattering. Next question is, Dash uses directional antennas to control interference. Yes, cell sectoring uses directional antennas to control interference. Thank you for watching this video.